Hi. Today, I'll show you how you can leverage AI to build an Python app using Omniston. First, let's see how you can navigate to the specific guide within our documentation. Simply head over to docs.ston.fi, then go to the Developer section. From there, select Quick Start Guides, and finally click on the Omniston Guide, Python. Once you're in the Omniston Guide, use the right side sub-navigation menu to locate the section titled Using AI Agents for Automated Implementation. Next, you'll need to install the Gemini CLI. Head over to their GitHub page, scroll down to the installation section, and install it globally using npm. Open your terminal and run the provided script to get started. After the installation completes, run the Gemini command in your terminal and authenticate with your Google account. Now, let's proceed by downloading the agents.md file. After downloading, open your terminal and navigate to your project location. To create a new directory, type mkdir followed by your desired directory name and press Enter. Then, enter this directory by typing cd followed by the same directory name. Finally, open this directory in your integrated development environment. In this example, we'll use Cursor, but you can use your preferred IDE, such as Visual Studio Code or other AI-powered IDEs like Windsurf. Next, paste the agents.md file into your project folder inside the IDE by drag and drop. Then, use your IDE's built-in terminal. Within that terminal, type Gemini and press Enter to launch the CLI interactive environment. Since the agents.md file is already in place, Gemini CLI will load it immediately and initialize the session using the project instructions. Next, you will implicitly prompt Gemini with Implement Omniston according to Omniston Guide, Python, in agents.md. Gemini CLI functions as a coding agent, acting on your behalf as a developer. It will plan and execute steps to implement the feature set. If at any point it asks for permission to proceed with an action, such as file modifications, allow it to continue. This enables the agent to perform tasks autonomously while ensuring your consent before critical operations. It will run for an estimated 5 minutes. After the implementation, if Gemini explicitly instructs you, just follow those instructions. If it doesn't, follow the steps I describe next. And if the agent has already done them for you, you can simply skip this step. Important. After the implementation completes, you must manually configure your TonCenter API key. Go to TonCenter and get your API key. Then create a .env file and paste your API key as TonCenter _API _key and save .env file. If .env already exists, replace the TonCenter key. With the implementation complete, I'll test it as if I were a user. In your IDE's terminal, go into the project directory by typing cd omniston python. Activate the virtual environment by typing source venv/bin/activate. If during the run you will see any error, copy-paste the error message to Gemini agent with a request to fix that. Then run. Python 3 omniston _CLI.py. You will see that it generated a new wallet with an address. Fund it with 0.25 TON for testing. After successfully funding, I will rerun the Python script. If the funds are there and we just generated a new wallet, it will take some time for this address to be deployed. Then the Python CLI will ask if we want to request a quote. You can check the swapconfig.json file for the from and to token addresses with proper decimals. In our case, TON is the from token and STON is the to jeton. We can specify the amount, which is 0.01 in our case, and proceed with the quote request. You can modify this and other settings in this file. Then we receive a quote of around 0.038 s-ton for 0.01 ton, so we proceed with the swap. After a few seconds, we can check if the transaction was successful.